My name is TS Ghosh, and this is my AQA A-Level Computer Science NEA testing video. So the first test that I have is checking if the application launches, and this covers the first objective. So if I run current script, you can see that the application launches. So if I exit from my application. My second test is that the welcome screen has information regarding Conway's Game of Life, and it explains the rules, and it talks about some of the applications as well of Conway's Game of Life, and the play button takes the user from the welcome screen onto the grid selection screen. So if I run the application, so as you can see, this is the welcome screen. Welcome to Conway's Game of Life. It has the introduction, it has the rules, and it has applications of Conway's Game of Life. And if the user clicks play, they can move on to the grid selection screen. So my third test is, and the second test that I did covers Objective 2, 2.1 and 3. The third test is the user going straight to the grid selection screen after they press play, so they don't read any of this, they just go straight to the grid selection screen, and as you can see, that works fine. And that covers objectives 2.1 and 3. So my fourth test is that the grid selection screen works, and the grid on the game screen takes the user's inputs on the grid selection screen as the dimensions. So if I run again, and I press play, so my input data is 30 for the width and 30 for the height, and this is boundary test data. So if I press done, the user should be taken to the game screen, and as you can see, the grid is 30 cells wide and 30 cells high as well. And this test covers objectives 3, 3.1, 3.2 and 3.3. My fifth test is testing the user inputs on the grid selection screen again, and this time the inputs will be 10 for the width and 10 for the height, and this is more boundary data because the range that the user can input is between 10 and 30 inclusive. So if I press done, as you can see, the grid is 10 cells wide and 10 cells high. And this covers objectives 3, 3.1, 3.2 and 3.3. And my sixth test is what happens if the user enters normal data for the grid selection screen inputs. So if the user enters 17 for the width and if they enter 24 for the height, as you can see, that is well within the range, and the grid on the game screen is 7 cells wide and 24 cells high. And this covers objectives 3, 3.1, 3.2 and 3.3. My seventh test is what happens if the user enters invalid erroneous data, and this test is testing what happens if you enter nothing into these two boxes. So if I press done and I've entered nothing, an invalid input error message pops up guiding the user to enter positive integers only. Now the seventh test covers objectives 3 and 3.2.1. And my eighth test is what happens if the user enters negative numbers for these two entry fields. So if the user enters minus 20.5 in the width entry and minus 25 in the height entry and then presses done, obviously this is not within the range, so an error message is thrown up guiding the user to only enter positive integers. And then my ninth test is what happens if the user enters positive numbers that are outside of the range. So if the user enters 31 in the width and if the user enters 9 for the height, which is outside of this range, and if the user presses done, an error message pops up, guiding the user to only enter values between this range. And this covers objectives 3, 3.2.1, and the 8th test also covered 3 and 3.2.1. My 10th test is when the user enters valid numbers into the width and height entries and presses done, that the user is taken to the game screen. So if I just do that now, so if I do 30 and 30, and as you can see here, the game screen has a blank grid which has taken the dimensions that the user has previously inputted on the grid selection screen, and there are lots of features. And this test covers objectives 4 and 4.1. Test number 11 is testing the feature guide popping up on top of the application and pausing the simulation, and giving the user all of the information about all of these features here. And so what I'm going to do to test that is draw a random initial starting pattern. So if I just draw something really random, okay, and then I press play, as you can see the simulation is playing and the generation counter is incrementing by 1. Then I'm going to press the features guide and it pops up on top and it explains all of the stuff, all of the different features on the game screen. And then if I close it, you can see that it has actually paused the simulation as well. And that test covers objectives 5, 5.1, 5.2, 6, 6.1, 6.2, 6.3.1, 8, and 10. And my 12th test is testing that all of the cells in the grid can be toggled to live or dead, so the user can actually draw any initial pattern that they wish. So if I just clear the screen, this isn't part of the test, but I'm just going to clear the screen. And so you see the generation counter has been reverted back. There are other separate tests testing those features. And so to test this, I'm just going to toggle a bunch of cells on the grid. So as you can see, I'm doing this completely randomly, and all of the cells that my mouse is dragging over, they are becoming activated. And if I just press as well, all of these cells are also becoming live cells. And every single one of the cells in the grid can be manipulated in this way as well. Okay, and this covers objectives 6, 6.1, 6.2, 6.3, and 6.3.1. Okay, I'm just going to clear the screen again. This is not part of the test, but just to get rid of all the live cells. So, my 13th test is testing whether the generation counter increments with every generation that the simulation evolves. And so to do this, to test this, I'm going to draw a random initial pattern. So if I just do that again, a completely random initial pattern. And I'm going to press play and then allow the pattern to evolve. And as you can see, the generation counter started at 0 and then is incrementing with every generation that the simulation is evolving to. And then I'm going to pause. And as you can see, the simulation is paused and the generation counter is paused too. Okay. And then I'm going to press play again. And the generation counter is still incrementing with the simulation. And then I'm going to press clear, the clear button. And as you can see, the grid of cells clears and all of the live cells are reverted back to dead cells, and the generation counter stops incrementing and reverts back to 0 when the simulation is cleared. And this test covers objectives 6, 6.1, 6.2, 6.3, 6.3.1, 7, 7.1, 7.2, 7.3, 8, 9, 9.1, 10, and 11. So test number 14 is testing whether the cells evolve in line with the rules of Conway's Game of Life. And to test this, I'm just putting 30 in the width and 30 in the entry. To test this, I'm going to draw a glider and then press play to see how the cell evolves. Because a glider is a very famous, well-known pattern, so you can see that the glider does indeed walk across the grid as it should in other Conway's Game of Life simulations. And then I'm going to press clear without pressing pause first to show you. And as you can see, the generation counter is incrementing. I'm going to press clear without pressing pause to show you that the clear button can be pressed when the simulation is running. And this test covers objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, and 10. Test number 15 is actually checking that the clear button clears all the live cells from the grid while the simulation is running. So to test this, I'm going to draw a random pattern and then press play and let the simulation evolve. And then I'm going to press clear, and as you can see, all the live cells are now dead, and the generation counter has been reverted back to 0. And this covers objectives 6, 6.1, 7, 7.1, 7.3, 8, 9, 9.1, 9.2, and 10. Test number 16 is testing the clear button again and checking it clears all the live cells from the grid, but when the simulation is paused this time. So to test this, I'm going to draw another random pattern. It's completely random. And then I'm going to press play and allow the simulation to evolve, allow the simulation to run. And then I'm going to pause the simulation, and then I'm going to clear the simulation. And the same thing happens, the grid becomes empty, full of only dead cells, the generation counter reverts back to 0 as well. Test number 16 covers objectives 6, 6.1, 7, 7.1, 7.3, 8, 9, 9.1, 9.2, and 10. Test number 17 is testing whether the simulation plays, pauses, and steps forward correctly. So to test this, I'm going to draw a random pattern. Then I'm going to press play and allow the simulation to play. Then I'm going to press pause. And as you can see, the simulation has paused and the generation counter has paused. And then I'm going to press the step button, which is over here, many times. So this is the first time I click it. And as you can see, the simulation only evolves to the next generation and the generation counter only increments by 1. I'm going to press the step button for the second time, and the same happens, moves forward by 1 generation. I'm going to press the step button again, and again, and again. And this test covers objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 11, 12, and 12.1. So I'm going to clear the grid now. Now, test number 18 is testing if the simulation rewinds properly to the initial pattern and if the generation counter decrements as well. So to test this, I'm going to draw a random pattern. Then I'm going to press play and allow the simulation to evolve. Then I'm going to press pause, and then I'm going to press rewind. And the simulation will rewind until the initial pattern is restored and the generation counter is 0. And as you saw, the generation counter decrements by 1 as well for every generation. So I'm going to clear the grid now, and this is the initial pattern that's been reached. And that test covers objectives 6, 6.1, 6.2, 6.3.1, 7, 7.1, 7.2, 8, 10, 11, and 13. So test number 19 is checking that the step button works correctly and moves the simulation forward by 1 generation at a time. And to test this, I'm going to draw a random pattern. And then I'm not going to press anything else like play. I'm just going to step right from the beginning. So this is the first time that I'm pressing the step button. And it increments by 1. The generation counter increments by 1 and the simulation moves to the next generation. Then I'm going to press the step button again. The same thing happens. And again. And the same thing happens. And I can press it multiple times, rapid succession, and the same thing still happens. Test 19 covers the objectives 6, 6.1, 6.2, 6.3.1, 7, 7.1, 7.2, 8, 12, and 12.1. And I'm going to clear the grid now. Test 20 is checking that the step rewind button works correctly and steps the simulation back by 1 generation at a time, stopping at the initial pattern. And to test this, I'm going to draw a random pattern. Then I'm going to press the step button a few times, just so that the simulation can actually rewind. So I'll press the step button a few times. And then press step rewind until the initial pattern is reached. And as you can see, the pattern moves back by 1 generation at a time, and the generation counter is also decrementing by 1 every time I press the button. And now the initial pattern has been reached. So this test covers the objectives 6, 6.1, 6.2, 6.3.1, 7, 7.1, 7.2, 8, 12, 12.1, 14, and 14.1. I'm going to clear the screen again, clear the grid. Test 21 is doing a mixture of these buttons in the corner here, in to show that the buttons work in any configuration. So what I'm going to do is I'm going to get the simulation to play, then I'm going to pause it, then step it forward, then rewind it, then pause it, then step rewind it. And this is to show that these buttons can work in any configuration in any order. And to test this, I'm going to draw a random pattern. Then I'm going to press play. And I'm going to let the simulation evolve. for a few generations. Then I'm going to pause the simulation. Then I'm going to step it forward. Then I'm going to rewind the simulation. And then I'm going to pause. Then I'm going to step rewind the simulation. And as you can see, all of these buttons have worked. The simulation executed these buttons without any difficulty. This test covers objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 11, 12, 12.1, 13, 14, and 14.1. So test number 22 is that the simulation changes the speed it's played at based on the speed slider over here. And to test this, I'm going to draw a pattern. Then I'm going to press play. And so this is currently at the slowest speed, as you can see by the value here. And then I'm going to drag this slider to a random place. And you can see already that it is moving a lot, the simulation is moving a lot faster. And then I'm going to keep dragging it. This is still moving faster and faster and faster. Then I'm going to drag it all the way to the end. And you can see that it's moving super quick now. And the simulation evolves based on the speed that is set by the speed slider. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, and 15. I'm going to clear the grid. Test 23 is that the simulation changes the speed it's rewinded at based on the speed slider as well. So the speed slider controls both the speed that the simulation plays at, the speed that it evolves at, and the speed that it rewinds at. And to test this, I'm going to draw a pattern. Then I'm going to press play, and as you can see, the speed slider is already at the fastest. So I'm going to slow the simulation down a little bit, and then I'm going to slow it down even further. I can speed it up again if I like. And then I'm going to pause. Then I'm going to rewind, and it rewinds at a very fast speed, or I can slow it down. I can speed it up again. I can speed it up to the fastest, and it rewinds back to the initial pattern. And so the simulation, as this has shown, moves at the speed that is set at the speed slider. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 13, and 15. So test 24 is that the live cell, dead cell, and cell border colours can all be changed, then the simulation plays as normal. And to test this, I'm going to change the colour of the live cells. So if I go into my colours here, I can press on live cell and pick any colour. So I'm going to choose this colour. And then I'm going to do the same for dead cells. So I'm going to choose dead cell, and I'm going to pick this colour for dead cells to be. And as you can see, the dead cells in the grid have changed to that colour. And then I'm going to choose border, So this is for the cell border. I'm going to choose this color. And as you can see, that has changed the color of the cell borders. Then I'm going to draw a pattern, and the live cells in this pattern should take the color that I chose a second ago, and they do, which is good. So I'm just going to draw a random pattern and then press play, and the simulation works as normal. It evolves as normal with the modified colors. I can change the speed and everything. I can slow it down. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 16, 16.1, 16.1.1, and 16.2. So I'm going to pause, and then I'm going to clear the grid, and that gets rid of all of the color settings that I have chosen, which is actually in the instructions in my colors window, as you can see here. So test number 25 is that my export button exports the pattern in the grid. And to test this, I'm going to draw a pattern. Okay, this is my pattern. Then I'm going to press export. This is the export button. And then I can save this file anywhere, but I'll just select this trial folder. And I'm going to save this pattern as 2 circles. Oh, sorry, I need to select the folder first. So I'm selecting the trial folder. And then these are all of the patterns I've already got. And I'm going to save this pattern as 2 circles. Save. And the pattern should now be saved as a .txt file. This test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, and 17.1. I'm going to clear the grid. So test number 26 is that the export button works even when the colors are modified. So if I modify the colors again, click on the colors window button, choose a color for the live cell. I'll choose this color this time. And then choose a color for the dead cell. I'll choose this color. And then choose a color for the cell border. So maybe I'll choose this color. And then I can draw a pattern. And then I can still export this pattern. I'll name it zigzag. And then this pattern should save as a .txt file, but not with the colors. It will just save as the base pattern with the dead cells and the live cells. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 16, 16.1, 16.1.1, 16.2, and 17.1. And I'm going to clear the grid now. Test number 27 is that the import button imports a pattern into the grid. And to test this, I'm going to first press the imports button, which is over here, and I'm going to choose a pattern to load. I can choose a pattern from any file that I like. So I could choose one from this trial file, and I'm going to do that. I'm going to choose the pattern that we saved earlier. I'm going to choose zigzag, and as you can see, it loads it onto the grid perfectly. It matches it up perfectly, and then I'm going to press play, and the pattern evolves like any other pattern would. I can change the speed as well. Okay. Then I pause, and then I'm going to clear the grid, and I'm actually going to try this out with a second pattern. So I'm going to open my imports by pressing import, and I'm going to load something that I saved a while ago. I'm going to double click to open, and this has saved as well. It saved when I exported it, and now I've imported it into the grid, and then I can press play, and this also evolves like any other pattern would in the grid. And I can change the speed. And I paused, and then I'm going to clear the grid. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, and 17.2. So test number 28 is that the import button works even if colors are modified. So to test this, I'm going to change the colors of the live cells, dead cells, and cell borders. So I'm going to do this now. Choose this color for my live cells, this color for my dead cells, and then this color for my cell borders. And then I'm going to press import, and I'm going to choose a pattern to load. So I'll choose two circles, why not? And as you can see, the live cells have loaded with the color that we picked. Even though the colors are modified, the import button still works. And then this will evolve as it should. Awesome. I'm going to pause and then clear the grid. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 16, 16.1, 16.1.1, 16.2, and 17.2. Test number 29 is the pattern the imported pattern will not import if it does not fit into the grid. So if the grid is too small. So for this, what I'm going to do is I'm actually going to exit the application. Then I'm going to run it again. And then go back to the grid selection screen. I'm actually going to input 10 in the width and 10 in the height, so my grid is quite small. And then I have my 10 by 10 grid of cells here. And then I'm going to press import and then choose a large pattern. So I'm actually going to choose this spiral pattern that I already imported earlier because I know that this is a big pattern, so I'm going to import it. And an error message comes up saying, please choose a pattern which will fit in your current grid. So it's guiding the user to choose a pattern which will fit into their current grid. And you can press OK. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 17.2.1, and 17.2.2. So test number 30 is quite a long one. The test is the user can choose a preset to load onto the grid, then watch the preset evolve. And to test this, I'm going to press my presets button, go into the presets window, and I'm greeted with lots of different presets. Here, there are 4 categories: still lifes, oscillators, migrators, and something called a Methuselah. And to test this test, I'm going to choose one of each and then watch it on my grid. So the first one, I'm going to choose a still life. I'm going to choose boat, and I'm going to watch it evolve. As still lifes don't move, they stay as they are. That's why the pattern isn't moving. Okay, I'm going to clear the grid. Then I'm going to go back into my preset pattern. I'm going to choose an oscillator. So I want to choose this one, pentadecathlon, and it's loaded into my grid. Then I'm going to press play and watch it evolve. Okay, awesome. I'm going to clear the grid, go back into my presets. Now I'm going to choose a glider, and I'm going to press play and watch it evolve. Okay, and it's evolving, it's walking across the grid. I can speed it up. I can slow it down. Okay, clear the grid, and then final pattern, final preset. Press the preset button, and then scroll all the way down to the Methuselahs. I'm going to choose Acorn. Then I'm going to press play and watch it evolve like any normal pattern. And I can speed it up as well. I can slow it down. Speed it up. Slow it down. Speed it up. Awesome. Clear the grid. And that's the end of that test. So all of the presets loaded onto the grid and they all evolved normally, like normal patterns. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, and 18. Test 31 is similar. The user can choose a preset to load onto the grid, then watch the preset evolve, even when the colors are modified. So to test this out, I'm going to change the colors of the live cells, dead cells, and cell borders first. So I'm going to choose the color of a live cell. I'm going to choose this color. I'm going to choose the color of a dead cell. I want to choose this color. I'm going to choose the color for cell borders. I'm going to choose this color. And then I'm going to load a preset onto the grid. So this time I want to load Beehive from the still lifes. I've loaded it onto the grid. It's taken the colors of live cells. And I'm going to press play and I watch it evolve as any normal cell. But because it's a still life, it just stays in the same place. Okay, awesome. I'm going to clear the grid. Then I'm going to choose colors for the live cells, dead cells, and cell borders again. And then I'm going to choose another preset. This time, I want to choose Pulsar from the oscillators, and it's loaded onto my grid. and I can press play and I can watch it evolve like any other. Change the speed, make it faster, make it slower. Awesome. Clear the grid. I'm going to choose the colours once again. Then I'm going to choose another preset. So this time I'm going to choose something called Backrake 1 from the migrators. And as you can see, it's loaded onto the grid. I'm going to press play and watch it evolve. This is currently the fastest speed, but I can slow it down. I can speed it up. I can slow it down. Awesome. Then one final time, I'll choose the colors of the live cell, dead cell, and cell borders. And then the last preset that I will pick will be Die Hard. And it's loaded onto my grid. And I can watch it evolve like any other normal pattern. I can change the speed. Awesome. Clear my grid. This test covers the objectives 6, 6.1, 7, 7.1, 8, 9, 9.1, 10, 16, 16.1, 16.1.1, 16.2, and 18. 32 is checking that the user can zoom into the grid and out of the grid. And I'm going to test this by first drawing a pattern. So I'm going to draw a random pattern now. And then these buttons are my simulation controller buttons. So I'm going to press the play button and then I'm going to zoom in. As you can see, the simulation is still playing. I can zoom in again and again and again, and I can zoom out too. I can change the speed while I'm zoomed in, and I can zoom out again. I can zoom in while the simulation is playing. Then I can pause, I can still zoom in, I can still zoom out. I can also step my simulation forward and still be zoomed in, although you can't see any of the changing cells. You can now at the corners. And then I could step rewind and stay zoomed in, or I can zoom out. I can zoom in again and I can rewind my simulation, and you can see some activity, and then we're back at the initial starting pattern, and the user can zoom in and zoom out essentially whenever they would like. And this test covers the objectives 6, 6.1, 7, 7.1, 8, 10, 11, 12, 13, 14, and 19. I'm going to clear my grid. Test number 33 is that the user can change the size of the grid via the grid select button. And the way I'm going to test this is I'm going to draw a pattern. Okay. and then I'm going to press play, and now the pattern is evolving. Then I'm going to press grid select, and as you can see, the simulation has paused and the generation counter has also paused. Do you want to change dimensions of grid? Your grid will clear. I'm going to click no. Then I'm going to play my simulation again. And simulation plays as normal. Change the speed, make it faster, make it slower. And then I'm going to press grid select again, and the simulation is paused once again. I'm going to click yes to this pop-up, and then I will change the width from 30 to 10 and the height from 30 to 10. I'm going to press done, and then we have a new grid in our game screen, which is 10 cells wide and 10 cells high. So the user can change the dimensions of their grid whenever they want to via this grid select button. This test covers the objectives 6, 6.1, 7, 7.1, 8, 10, 20, 20.1, and 20.2. Test 34 is testing whether the user can go back to the welcome screen from the game screen at any time. And the way I'll test this is I'm going to draw a pattern. Then I'm going to press play and let this pattern evolve. Maybe change the speed, zoom in, zoom out. And then I'm going to press this welcome button. And as you can see, it's taken me back to the welcome screen, and I can stay here for as long as I like. I can read the rules again, read the introduction. I can stay here, read all of this information, and when I press play, I'm taken back to the game screen. My simulation has been paused, and it is exactly how I left it. This test covers objectives 2.1.1, 6, 6.1, 7, 7.1, 8, 10, and 21. Test 35 is testing that the user can revert to their initial pattern. And the way I'll test this is I will draw a pattern. Okay. And then I will press any simulation controller button. So I could press play, change the speed. I could zoom in, zoom out, change the speed again, pause, step rewind, rewind. And then I can press the reset button, and the grid displays the initial pattern that I drew onto the grid. This test covers the objectives 6, 6.1, 7, 7.1, 8, 10, 11, 12, 13, 14, and 22. Test 36 is checking if the user can exit the application at any time. And the way I will test this is I'll first launch my application, and then I will press exit from the welcome screen. Exit, and it comes up with a message box asking if the user wants to exit without saving their pattern. So I can say yes, and the application closes. And then the next way I'll test this is to exit from grid selection. So this is my grid selection screen. I can exit from this screen too. The message box pops up again. Yes, confirm, and then the application closes. I will launch again, and then I will enter the width and the height that I want. Press done. Then I'm at the game screen and I can exit from the game screen too. Press yes. Application closes. Launch my application again. Press play. Enter some integers. And then I'm going to draw a pattern. And then I'm going to play my simulation. So it's actually running right now. Yep. And then I'm going to press the X. And then I can also exit while the simulation is running as well. Test 36 covers the objectives 1, 6, 6.1, 7, 7.1, 8, 10, 23, and 23.1. And I would also like to add, as a separate note, that all of the tests that we've done where where I drew a pattern to begin with, all of those features can also be used on presets, and it does not matter what color the grid elements are. So they work with any colors and any presets, any patterns. Thank you. So I have a few extra tests which don't test my objectives. But I wanted to show these in the video because they show that my application is really robust. So test number 37 is testing that all the simulation controller buttons work on presets as well as normal patterns. So if I run my code, press play, I'll just put in 30 and 30, press done, and then I will load a preset onto my grid. So I'll load this big one, backrake 1, and I will test this by pressing a mixture of these simulation controller buttons on the preset. So if I press play, the preset plays as normal. The speed slider works as well. I can zoom in, I can zoom out, I can pause, I can rewind. Okay, I can step forward, I can step back, I can play it for a lot faster, zoom in again, out, pause, and I can also reset the pattern. And so this test has the expected outcome. Test number 38 is testing whether the play button can be pressed or not multiple times if it's already been pressed. And the reason I'm doing this test is because in earlier versions of my code, when the play button was pressed multiple times, it started multiple play loops, and that actually messed my simulation up. And to test this, I'm going to get a preset up instead of draw a pattern, because what used to happen was when this preset was evolving as normal and the play button was pressed multiple times, it would actually stop being an oscillator and the generation counter would jump in like 10 increments at a time. So that was obviously not what I wanted my application to do. And okay, I'm going to test this now by pressing play. Speed is quite high, I'll turn the speed down a bit. I'm going to press play again, and I'm going to press it a couple times. And as you can see, the generation counter does not skip generations, and the oscillator stays as an oscillator. I can press it more times, and this is showing that my application is robust and doesn't allow for these errors anymore, and the pattern is evolving as normal. Okay, I'll pause and clear the screen. And test number 39 is testing the same thing with the rewind button. So I'm going to load another preset. I'll load a back rake again. This is a great pattern. So to test this, I'm going to press play first so that the pattern can evolve, so that there is something to rewind back to. So it's evolving as normal. I can try pressing the play button, but it doesn't let me. Okay, I'll pause it there, and then I'll now press the rewind button, and I'm pressing multiple times, and as you can see, it doesn't let me. The generation counter moves back as it should, and now we're back to our initial pattern. So the pattern evolved as normal, and it rewinded as normal, and the generation counter does not jump as well. Test number 40 is that the user clicks on a cell that's outside of the grid index when the grid's not 30 by 30 cells and the application does not stop running because of an index error. And to test this, I'm going to put 10 for the width, or actually let's put 15 for the width and 15 for the height, because I don't think we've used these numbers before. I'm going to press done, and as you can see, this whole black section is actually just the Pygame window, and this is the grid that we can work with. So if I draw anything and then press in the Pygame window, it doesn't matter that it's outside of the grid, it still works just fine. And while I'm here, I'll actually also show that all of the color settings and everything still work on a smaller, like modified grid. Okay, and as you can see, still absolutely fine, and the game still plays, the simulation still plays as normal. I can do some more. Awesome.